Okay, so now it's recording. Okay, so start the perpendicular line to line M 3 P. You know how to do that. By the way, the reason I'm recording it, I'm going to be going just like 2 periods in the middle of the day for an appointment that I have to go to. We have
Like the circle or the half, like an arc going through both sides of the line. And then you go from the point where the arc in the left sets. One arc to the other.
if you make it bigger in between, now we can do it, but it has to be the same from both of these, from here and from here. And then okay, so that would be perpendicular. Is there questions? I only gave them out yesterday. Anybody else in the practice? Okay. So that was that. Practice. Now the orthocenter is the point where all 3 altitudes of a triangle intersect. Point where all 3 altitudes of a triangle intersect. Okay. So an altitude, we all know how to do an altitude. That was the multiple choice question in the test. They had that right. That was the answer to that one, and pretty much everybody got it right. And now it says construct the altitude, the orthocenter, excuse me, finally to be safe. So you could do all 3 altitudes, but we don't. We only have to do 2. And where the 2 altitudes meet, that is the orthocenter, where the 2 altitudes meet. So I'm going to do, can I get the compass from here? I'm going to do it from, I'm going to do it to BA, the altitude from C to BA. So I draw the arc. And then I go from here. I draw an arc. And then I go from here. I draw an arc. Up. Okay, so look, my first arc did not meet. So I'm going back. I have to make it longer. So this one had to be longer here. And then I go over here and I do it. And you just correct, okay? So now I'm going to draw the altitude from here down to there, which I can't even see it. So I'm going to try to make the view a little smaller. Let's see if I. Okay. Okay, so that's the one altitude, right? The altitude is actually from C to where it hits AB. That's the actual altitude, but you extend the altitude. And sometimes, I mean, you can have to extend it in both directions. It can be above, below, that we'll see. That was the first one. Now we're going to do the altitude to side AC. I'm going to change the color. So the altitude to side AC, excuse me, that would be able to be. And I have to make sure that I cross. There, I have to cross it twice, right? That was supposed to work. Okay, if I couldn't, you can always extend the side of the triangle. You are allowed to do that. There's our extend. Now I'm going to go from here. And this is big. I don't even have to. This has to be, it doesn't have to be that big. So I need to mark here. And then from over here. And then I'm going to draw, what am I going to do next? Okay, thank you. Then I'm going to draw, what do I have to do next? And so I'm going to draw from B to that point of intersection. Okay. We have now the orthocenter. The orthocenter is where the altitudes meet. The orthocenter is where the altitudes meet. Now, with the orthocenter, sometimes it could be outside the triangle, and sometimes it could be on the triangle. So unlike the centroid, which we learned already, the centroid is always inside the triangle. The orthocenter could be on the triangle, or it could be outside the triangle. When you look at this triangle, what kind of triangle does this look like? Acute, right, or obtuse? Sammy? I mean, Riley, excuse me. This is acute. All the angles are acute. Okay? So if we had a right triangle, doesn't look like it, right? I messed up. That's a vertical. That's a horizontal. So if we had a right triangle like this, right? This is a right angle. If we did the altitude from here on this one, the altitude would actually end up being here. Like we would extend this. We would extend this. And then we would do the whole thing, and the altitude would end up being here. But do you want me to? I'm not going to do it all out because I don't want to make sure we have to do the whole lesson. And then if we did it over here from this to this side, if we extended this, and I did the altitude from here, it would actually end up being here. So the orthocenter would actually be on the vertex where the right angle is. You see that? So the orthocenter on a right triangle is actually on the right angle itself. Now, if we had an obtuse triangle, that's an obtuse triangle. If we did the whole, draw the altitude and draw the altitude, okay. I'm going to show you that the orthocenter is the outside. Well, you know, I'm not going to actually do it. I'm just going to show you all. So if you wanted to do from here to here, let's say that was one altitude, right? And then the one coming from here to this side of the triangle, right? If you extended this, and then you brought this right down over here. You see that? You guys see what I did? So here's one altitude right here. Here's another one over here. The two are meeting all the way down there. If you wanted the altitude to this side, and I extended this, and then I brought this down to be perpendicular. You see how it's meeting over here? So that's a right angle over here. I'm just drawing them without doing the constructions. You would have to do the constructions for everyone. Do you understand? You'd have to do the actual constructions. But look what would happen. I just want you to see that here is the orthocenter on the obtuse triangle. So the orthocenter on an obtuse triangle is outside, the acute triangle is inside, and the right triangle is on it. Okay? For a right triangle, it's on the right angle. For an obtuse triangle, it's outside. You got it? Everybody have it? Yes.
On our piece of rent, we feel like we have more space.
Of course, whatever I would have you do, would have to have enough space to do it. Okay? Okay, so let's see what else. The incenter. The incenter is the intersection of the angle bisectors of a triangle. The intersection of the angle bisectors of a triangle. The incenter is the center of the triangle's incircle, the largest circle that will fit inside the triangle and touch all three sides. Intersection of the angle bisectors of the triangle. That's what the incenter is. The intersection of the angle bisectors of a triangle. In other words, where the angle bisectors meet. The incenter is the center of the triangle's incircle, which I'll show you in a minute, the largest circle that will fit inside the triangle and touch all three sides. Okay. So I'm going to do two angle bisectors. Then you do an angle bisector. Yeah.
You make an arc going through both lines. Arc in the line. On the other side.
That's one. More than the other, you want to say it again? Go ahead. And okay. Where those two meet, if you did the third, it should meet in the same spot. But where those two meet is called the incenter. The incenter, that is a construction to actually find, here, let me press it, if I get that, hold on. That point right there, that's the incenter. Now, this part here is not part of the construction. You do not have to do this. Okay. You see that? That's the end circle. The end circle is the largest circle that will touch all three sides. The incenter is equally distant from the three sides of the circle. All the points in a circle are the same distance from the center, right? Every point in a circle is the same distance from the center. Well, where it hits the side, that distance from here to here, I'm gonna erase this in a minute, but here to here, or from here to here, or from here to here, all those are congruent. You understand that? So it's equally distant from all three sides. But when you do that, when you do the distance between a point and a line, it has to be perpendicular. So all of these, to even be able to do that, would have to be perpendicular when you measure it. You're not just eyeballing it. These would each be right angles there. That's not part of construction. The construction was done when we found the incenter. So I'm just showing you that the incenter is equidistant from the three sides of a triangle. The incenter is equidistant from the three sides of the triangle. Incenter be outside the triangle, and the incenter be outside the triangle, right? Nicolette?
No.
Okay, you go through it. Everyone agree? Why not? It's the center of the circle, which is inside the triangle. So there's no way it could be outside the triangle. So the incenter is always inside the triangle. Always inside the triangle. So far, the centroid was always inside. The centroid was always inside. The orthocenter could be either outside, inside, on, and the incenter is in. Look at that, it's in the name. Incenter, in.
What is the incenter to all of them?
Yeah, it would hit in the same spot. If I did the third angle bisector, it would go right through here. We only have to do two because we found it now, and they don't make you do extra work. And math, the mathematicians, They stop once you get what you need, okay? But if someone did it, they wouldn't lose points or get it wrong. You just don't have to do it. Okay, any questions? In the diagram below. So there's bracket columns, but then there's also a sheet column, right? Measured angle FEC. FEC is 84. And by the way, point B is the incenter. If point B is the incenter, that's where the angle bisectors meet, which means that this and this are congruent. This and this are congruent. And this and this are congruent. Do you guys understand that? It's where the angle bisectors meet. So therefore, those, it's the incenter, those must be angle bisectors. So now, if FEC is 84, what do we know? If FEC is 84, what's wrong? Good. So this would be 42 and 42. Half of 84 is 42. Angle ECF is 28. Angle ECF. So what do we know from there, Sophia?
Each one is equal.
Determine the measure of angle BRC. BRC. So there's different ways you can go about getting it. Anyone have any ideas? Brian?
Define the angle of EBC.
Yeah, how do you do that?
By adding 42 and 42.
If that's 124, then what?
180 minus 24.
What's like an R?
CDR.
That's 56. And then that's 70. And then process, ask a question if you're not sure. You guys understand that? You understand what we did? Nicolette?
Add 42, 42, 42.
That would give you the third angle over here, right? And then you'd have to divide that by 2, which would give you each of those. So then you still, then you'd have this and this, but you're still missing this angle over here. If you wanted to use the 180 there. This is the most direct route. Do you guys see it?
I just did 42 plus 28 and then subtracted, got 70 and subtracted that from I mean, from 180 and got 110.
Okay, say it again.
42 plus 28, because you know that.
Oh, that's a great way. Okay, let me show that one. Nice. So you said you have this triangle, the big triangle that you used is this one, right?
Yeah.
So you said 42.
You did that, like that angle.
Yeah, 42, perfect. 42 plus 28, 70. The three angles are turning up that of 180. 180 minus 78 is 110. Really nice, Isabel, nice. You guys see that? But they're both right. There's no wrong, you know, if you're getting the right answer and you're doing it right, you're right. Okay? By the way, you have to start like learning the names, like just so you know which one's which. Because on the test, like, you got to know, like that's the hard, you know, for some that's the hardest part is knowing which one is which. Okay, the centroid is where the medians meet. The orthos, oh, here's my orthocenter. The orthodontist, listen, orthocenter, orthodontist. When you have to go to the orthodontist, your parents might think sometimes you have an attitude, they have to go to the orthodontist. Attitude, altitude. Anyway, like that? Orthocenter, orthodontist, attitude, altitude, anyway. There's also a whole acronym I'm gonna give. Which I'll give it to you after, which shows you a trick to memorizing all the names. Numero dos. In the diagram below, CD is the bisector of angle BCA. CD is the bisector of angle BCA. So that means that this is prime to that. AE is the bisector of angle CAD. And BG is drawn. Well, now, this is a question on the test that a lot of people got wrong, so pay attention. A lot of people got this wrong. They did not say in here that BG is an angle bisector. But I know it is. Jen? No, I'm saying, but no, I'm saying, why do I know it is? Yes, it's drawn, thank you, Jim. It's going to the incenter. The incenter is where the angle bisectors meet. They're meeting at G. So if this is going from B to G, it's going to the incenter. That must be the angle bisector, or else why would they go into that exact same spot? Does that make sense? Okay, so which statement must be true? And that's, I believe, what Ginger said, number 4, angle DBG and angle EBG must be congruent. Good, Jen. You all understand that one? This topic, they changed the regions a little bit. This used to be on the regions. Now it's not as much on the regions. And last year with COVID, it was not spending much time on with, every other day. And they, that was one of the things that the juniors now might not have done as much of, but now it's back in. Is that all of it? Okay. Your homework is the sheet that says incenter and orthocenter homework, and you may begin now. Any questions? Oh, thank you, Devin. And I'm going to give back your test now. I'm going to stop the share. Wait, no, I'm going to record.